Today we're developing triangle similarity. Your essential question is, how do I identify similar triangles? Learning intention. I'm learning to identify similar triangles and to use them to find unknown quantities. So you have two warm-up questions. Find the missing measures using trigonometry. Pause the video and see if you can do that now. So hopefully you tried. If we're looking at this, we've got to decide whether we're going to use sine, cosine, or tangent. Remember that acronym SOHCAHTOA. Sine, opposite over your hypotenuse. Cosine, CA. Cosine is your adjacent length over your hypotenuse length. And finally, TOA. Tangent is your opposite over your adjacent. So if we're looking for x, what two pieces do we have? Here's your angle. This would be your opposite. This would be your hypotenuse. I look over here, opposite and hypotenuse is sine. So the sine of 70 degrees is equal to x divided by 20. The opposite of dividing by 20 is to multiply by 20. As I'm getting ready to start, I always do, first check is to make sure I'm in degree mode. Your mode button's right there. I am, so I hit second in mode. Now, 20 times the sine of 70. And I end up with 18.79, which is about 18.8. And that would be centimeters. For the next one, I'm looking for x and I'm looking for y. Once again, if this is my angle, this would be my opposite. This is my hypotenuse. And this is my adjacent. So, opposite and hypotenuse is sine. The sine of 50 degrees is equal to x divided by 12. Multiply both sides by 12. Twelve times the sine of 50. And you end up with 9.19, which is about 9.2. And that would be units because we don't know what units we're in. Okay, for y, this time we've got the adjacent and the hypotenuse. That's your cosine. So the cosine of 50 degrees is equal to y divided by 12. You still multiply both sides by 12. Twelve times the cosine of 50. And I end up with 7.71. So y is about 7.7 units. We don't know what units it's in, but we need to identify. So let's start looking at triangle similarity. When you're looking at these two triangles, what do you notice? Well, they're not the same size, but they've got two congruent angles. two corresponding angles are congruent. Okay, now think even harder. If two of them are congruent, what do we know about the third? Well, the third have to be congruent too. We know that angle A is congruent to angle D. Angle B is congruent to angle E. By the triangle sum theorem, we know that angle C has got to be congruent to angle F. Because they all have to add up to 180. If two of them are equal, then the last ones also have, if two of them are congruent, then the last ones have to be congruent. So your angle, triangle, similarity, you do not need to say all three of them are congruent. So if you are looking at this, you only need two angles, not three. If two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. If you notice, congruent has the equal sign, similar does not. Same size, same shape. That's what the equal means, it's the same size. The similar means it's the same shape. Not necessarily the same size. Okay, now, we're looking at the SSS triangle similarity. If three what? SSS stands for sides. If three sides of one triangle, this time they are not congruent, but they are proportional. To three sides of another triangle, then the triangles are similar. And that would be that little sideways S. Okay, given these two triangles, prove that they are similar. What do I have to do? Well, I've got to look at the fractions. So I'm actually going to go from triangle to triangle. The smallest side here is 6. When I compare them, I'm comparing them with division. So this is the smallest, 4 is the smallest. 9 is the middle, 6 is the middle. 12 is the largest, 8 is the largest. Now, the easiest way to compare is to change them into a decimal. If the decimal is kind of ugly, then we use it as a fraction. 6 divided by 4 gives me 1.5. 9 divided by 6 gives me 1.5. Guess what 12 divided by 8 is going to be? 1.5 again. Surprise, surprise. And we've just proven that they're similar because all three of the corresponding sides are in the same proportion. And this brings us to the side angle side. Remember when we had congruencies? We had side angle side, we had side side side, we had angle side angle, angle angle side, hypotenuse leg. We had 5 of them. But for the triangle similarity, you only have 3. So if two sides of one triangle are proportional, to two sides of another triangle, and their included angles are congruent, then the triangles are similar. Prove or disprove that these triangles are similar. Okay, so do I have an angle that's congruent? Because I only know two of the sides. Remember back to the first angles that we proved were congruent are the vertical angles. These are congruent. So we have the congruent angles. These are the sides that are included with that included angle. So we're going to look at the largest with the largest and the smallest with the smallest. It's kind of, when you look at 49, you want to put 8 with it. But if you notice, 49 is the largest, 14 is the largest, 28 is the smallest, 8 is the smallest. So it kind of is counterintuitive of what you think will happen. So 49 is my largest side. 8 is or 14 is my largest side. 28 is the smallest. 8 is the smallest. So 49 divided by 14 is 3.5. 28 divided by 8 is 3.5. So the triangle MVL is similar to triangle TVU by side angle side. So if you notice, M to V is the largest side, T to V is the largest side, V to L is the smallest side, V to U is the smaller side that we know, and they are similar. So how do you know you're successful? When you can identify similar triangles and use them to find unknown quantities. So this is triangle, similarity. You've got your angle, your side, and your side, angle, side. For the sides, they've got to be in the same proportions. For the angles, they have to be congruent. And hopefully that explains what you're looking for.